We cannot use point sources for this because guess what happens when you have a point source? Can it be magnified? No, a point source will remain a point source. So now we're going to do our extended objects. So I'm going to try to draw this. Let's use it for mirrors. This is my height. Call it H0. Is this true? If this is my center of curvature, is this theta going to be the same as that theta? Yes? Okay. So when we have an extended object, it has what we call transverse dimensions. In other words, it has a height, usually represented at H0. If I call this distance S, can I extend this one backwards? Can I also have another ray that comes through here and goes through my center of curvature? So that means my image will be formed here. Let me call this distance S prime. If I call this angle alpha, that angle alpha, look at the geometry. Number one, is theta I equal theta R? And number two, is theta R the same angle as alpha? So these are called alternating. And this is what we know from law of reflection. So from these two, may I call theta I equals alpha? May I also use the inverse of the small angle approximation and call this sine of theta I equals sine of alpha? So I'm doing the opposite of what I did before. So then may I call this H over S, H0 over S, and may I call this HI over S prime? Everybody understands how we can use small angle approximation both ways, right? Okay. Or may I rewrite this as H0 over HI equal S over S prime? Where in general, I call my S over S prime as O over I. Since this is true, we decided to come up with a name for this. And they decided to call it lateral magnification, or just magnification for most purposes, defined as HI over HO or S prime over S, or image over object. However you want to calculate it. You can calculate it by knowing the heights of both or calculating the object and the image distance to a very good approximation. Now, you remember I always used to put a minus sign there? What does that mean? So a minus sign in here, if I don't use a magnitude, they usually call it as HI over HO or negative I over object. And that has to do with this negative sign, tells us when the image is inverted or upright. So when you have a positive magnification, it tells you that the image is upright with respect to the object that you have. When it is negative, it tells you that it is inverted with respect to the object that you have. Doesn't tell you whether it's real or not. It just tells you inverted or upright.